guys, I know this is a slightly different perspective than what you're used to, but I wanted to make a video showing you my workbench, how it looks like during the week when I'm not making videos, because today's gadget might help solve a lot of my problems and your problems. This is the typical disarray of the back office, and I keep trying to clear it out, yet more stuff just appears. But I do work on a lot of projects, I've got a lot of interests, and I'm working on a lot of electronics projects all the time. And you can see this is my latest one. We're going to be going through this. This is a power supply I've been designing. And you can see that I've got multiple measurement tools here. They're not actually living on the shelf anymore because I tend to drag them out to use them out and about, and then they never get put back. So I've got set up here the oscilloscopes. You can see these 4 oscilloscope probes, and they go here. And I've got it here sitting vertically. Of course, that's not optimal because I have to keep looking over. And I don't show you the oscilloscope that much because it's really hard to fit under the camera, because the camera lives there. And you can imagine if I had the oscilloscope on the bench, it would be sitting here 2 inches away from the camera and you wouldn't see anything. So that's why when you do see oscilloscope action, it tends to be from one of these. This being the DSO shell, and I did a video on this. You buy them from Amazon or eBay in either fully assembled or semi-knockdown kits. I think this was a semi-knockdown kit and I assembled it during that video. And you see I've got a battery hanging off the end, and I've got an old oscilloscope probe, and it's okay, it's actually pretty good. And in addition to that, I do use this guy, and that of course is the Isotech IDM 19 Pokit multimeter. It's pretty much auto ranging. It's only got a couple of mode switches, so it's very easy to switch in and out where you want it. But most importantly, it does have this nice cable system on the back that lets you hook those probes away when they're not in use. Can you do it with one hand? Just about. Look, there you go. So that's really nice if you like to have a voltmeter on the go, multimeter. In fact, that's the only one I use. It's featured in every video. And of course, when I can, I do buy spares. I do have a spare, and I did pick this up on eBay. I think it was about £15, really cheap. I mean, these are really quite expensive meters, so keep an eye out. Occasionally you might see them going at a bargain price. If you do see them at a bargain price, just snap them up. So today's gadget though is going to hopefully remove a lot of those issues and help me show you what I'm seeing during videos, and that is the Pokit portable multimeter, oscilloscope and logger. And if it can do all these things, I would be over the moon. So let's clear the bench a little bit so we can have a proper look at this gadget. It comes in this nice box, and you can see really quite glossy pictures on the back. Look at that, it's kind of some sort of overprint there. But it says it's got AC/DC voltage, AC/DC current, resistance, diode polarity, continuity and temperature. Great, that's multimeter mode. Oscilloscope mode, AC/DC coupling, AC/DC current, spectrum analyzer, triggers and a cursor. Yes, all the things you want. Logger mode, AC/DC coupling, AC/DC current and temperature, and that is fantastic. Logging is not something you normally get with most devices, and having that ability on something you can literally put on your keychain would be absolutely fantastic. There is a small limitation on it, but which is probably not a massive limitation for most of you boys and girls at home, and that is that it only takes a 60 volts DC range and a 42 volts AC range. So as most of you are probably just still playing with normal microelectronics, microcontrollers, around 5 volts, 12 volts, no problem, even up to 30 volts if you're playing with solar, things like that. But if you are intending to work on mains projects and things with power supplies, start to be a little bit careful, because some of those things can put out those high voltages, and it's bound to fry that. Now you do have all the other specs here. I have to admit, I don't really know the specs of the meters I buy. I just buy them and they seem to do the job. So if you've got a particular requirement for the tolerance of your meter, then you might want to investigate that more. But as far as I'm concerned, it's probably fine. Battery life, 6 months. Of course, we're quite interested though in just getting going with it. So there's the meter. There appears to be 2 test probes and this little guy. That's interesting. I wish more multimeters came with that, and that is a fuse. And in fact, it's on a little piece of a push out so that you can keep it without getting lost. Probably asking yourself, why do I need a fuse? And well, that's because you can of course blow the fuse when you're in current measurement. And just looking at the paperwork here, it says up to 2 amps, so I suspect that's a 2 amp fuse. I'm not going to be trying that out because it's not fun to blow a fuse in your multimeter because it normally stops working after that. So we're going to take all the parts out, and it does look like it comes with a lovely little pouch, and I suspect that's why that little thing pushes out there, so you can pop that in there and you have your fuse on you at all times, and that's groovy. I think I'd be more inclined to keep it in this pouch than keep it on my keychain, depending on my job, but I think that is a lovely little solution, isn't it? I mean, that for something that you can just bring on you, especially if you're like me and I tend to do little jobs when I'm on my holidays. I've been known to fix air conditioner systems in hotel rooms. I shit you not, I have done that. I've used knives from the kitchen and things like that instead of screwdrivers, and my razor blade to actually strip the wire. Right, but I digress. So the meter's this tiny little thing. I wish I had a ruler, I don't, but you can see it's less than a thumb's width across. There you go, middle finger across, and fits in the palm of your hand. That's the size of it. It takes, looks like a CR2032 battery. Come on, it doesn't want to open. Oh, there we go. It is a CR2032 battery. It does look like it's just the one, so that's fine. In fact, that's probably a good idea as well, is just to get a card like this and chop out one of those and pop it in there. This is CR2016. By the way, the numbers, the CR2016, CR2032, etc., refer to the thickness of it. So sometimes if you can get a thicker one in, you'll get way more use out of that. Now the probes themselves just pop off the side. I did see that in some literature. They're a little bit curvy, and you're saying, well, those don't look like very good probes, do they? They're not really long enough to probe anything. But check this out. Whoop, hello. It looks like a kind of something that wants to hug you with its claws. That's it activated now. So it's on, it's activated, the probes are out, and they're little things like this, and you go, dee, 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 dee. They're like quite diddy. I have to admit, they are quite diddy. But look at this. For your logging and further probing action, you can put on the clips, again, just like your oscilloscope, and then clip them onto your circuit, because of course it is also a DSO. That was a good idea, actually. I might just do that now. Keep it with the fuse. I've downloaded the application. It's called Pokit Meter. I'm going to hit that. Oops. Let's zoom out a bit. Thinking. In fact, has it actually just connected already? Let's have a test. I think it might have connected already. I've got a battery here. Wow. I'm going to take off those clips. We're just going to go for some probage, and I'm going to probe in reverse. Minus voltages. Look at that. Minus 1.5 volts. Woohoo! So you get the idea. It's using Bluetooth to connect straight to your device. You can hit temperature, 20 degrees. That's the ambient temperature. It's got a temperature sensor in it. Continuity. And that's actually, that's pretty responsive. I'm almost wondering where the sound comes out of. 1 second. The sound definitely comes out of your phone. It was so loud and non-directional, the sound, that it comes out of your phone. That's brilliant for continuity. Diode checking. So if you have a diode, and I do, see that guy? He's right there. So those are the 2 diode legs. Let's see what happens when we probe them. I'll zoom out a bit so you can see what's going on the screen. So we're going to try one way. Nothing! And then I'm going to turn it over and try the other way. Something. So it's going from 0 to 1. So you're getting current flowing in that direction, which is great. And you're not getting current flowing in that direction, which is correct. If you're like me and you're bad at resistors, you use one of these gadgets, which is a component identifier, and you chuck it in, click the button, you can see it saying testing, 4,763 ohms, so a 4.7 kilo ohms resistor. And I think this could probably replace some of this, certainly the resistance side and the diode side, because now we can put it on a resistor, and let's have a check. Let's see what it says. 4.47. Didn't that just say 4.7? Let's see who is more correct. Now I'm going to trust. This is my reference, but we're going to have to trust it. And you can see actually the screen is kind of similar, where you've got the bar graph and then you've got the display. I quite like that it says inf. Inf to let you know nothing's connected. And that's saying 4.63. So I don't know. What should we do? Split the difference between all three? We know what it should be. It's probably a 4.7K. We're talking a yellow, purple, red. So yeah, I don't know. Is there a calibration on this? It's close enough. It's close enough. Again, I don't know which is actually the reference here. AC current. Switch to current mode. So AC. Oh, sorry, that's not AC. Actually, that's interesting. It can measure AC current. And I'm thinking we're measuring AC current, but quite a low voltage, aren't we? We're saying it's an AC current. AC current, where are you? Sorry, 1 milliamp to 2 amps, but the AC voltage was 42 volts. So the current will be the same, right? Don't go over voltage. In fact, it says here in the corner 60 volts maximum. You want to be careful. I don't know how to test AC current. We could use one of my circuits and test it on the transformer side, but that's too much faff. So if you've got the need for AC current, great. If you do, comment down below. What low voltage AC currents do you normally measure? DC current, though, is where we'll normally be playing. And of course, switch to current mode, switch. That is where you're going to have this in circuit. So you're going to have your battery, your lamp, this, and then back to the other side of the battery. And that's how you're going to measure your current there. I've got no doubt that's going to work. So we trust continuity. We've tested temperature, voltage. Well, I think it's time to get my power supply circuit and actually probe some of the more complicated things, because that way we can actually test additional features, but also the digital storage oscilloscope function. And while I'm setting up, I thought I'll turn this off to save power, but check this out. There's a little button on the bottom. Ding. Away we go. So we're ready to test now. I have my toroidal transformer sitting here, and I'm going to hook that up. Now this toroidal transformer has 2 input windings and 2 output windings, and that's why there's 4 wires on the output. So I've got these handy little dandy wires that I've hooked up. So I'm going to go between the outputs on each of the output coils, and they should be reading 17 volts, yes, on that side, and 17 volts on that side. And no matter which way around I go, you can see it's reading 17 volts. There's no polarity issues whatsoever. You don't get a minus 17 volts. But interestingly enough, if you actually are using this as part of a symmetric power supply like this, you really need to know the phases, because it's not center tapped, it's 2 separate coils. You have to get them the right way. So unfortunately, that's one use case where this won't help you. But the datasheet might, so that's great. But we'll move that along. That was a good example, and that worked well. That is indeed a plus minus 17 volts power supply. Now we have this other one here, which is a center tap power supply. I keep saying power supply, don't I? Transformer, that's a power supply when they're combined. This is on the shelf actually. It's a 9 volts, 0 volts, 9 volts. So that's what each of those wires are, black being the 0 volts. But it's made by Archer, and congratulations to Jenny List. Please go on and say hi to Jenny List on Twitter for answering this correctly, because I asked the question who made the Archer products, and she correctly identified it as Radio Shack. And I'm saying it like as if it was a challenge. It wasn't a challenge. I had no idea who it was, and then loads of other people said it was Radio Shack, Tandy, and I was like, yes, okay. So Jenny, you win though. You were the first person to say it. So now I'm going to hook that up. First time. Probably first time in like 30 million years. This is an old buy. Okay, so I don't even know now if this is working at all, because I've never used this. So hopefully we're going to see somewhere near around the 9 volts. Look at that. 9.7 on that side, and then 9.7 on that side. So that is absolutely fantastic. Now we can go a little bit further. So I'm going to switch out now using the menu to the oscilloscope function and tap Pokit to acquire data. Okay, so I don't know if it's continuously acquiring data or I have to set up some sort of trigger, but let's play. So if I now, in fact, look, we've got these guys. Let us hook these on. Oh, that reminds me, by the way, just before we jump over there, we'll go back to multimeter. We're in the AC. If you actually connect between the two outer ends of this power supply, you'll see 19 volts. Okay, so that's kind of like the AC sine waves you're doing, going from plus 9 volts to minus 9 volts. So you're seeing that 19 volt swing. So that's good. We're going to use that. We're not going to use that black center tap wire for this test. So I'm going to hook these probes on. Basically, think of it as a potential divider. So if you use the black center wire, you're halving the coil, right? So that's why you'll end up seeing half. So don't worry about that detail. Don't worry your pretty little heads. We're going to be checking this out. Right, so let's see. Trigger auto I'd quite like to do. Is there a line you have to set for the trigger? Volt window 10 volts. Let's see what happens. Oh, there you go. Look, you can see it there. What's going on? What's going on? So that's kind of a sine wave. Let me fiddle with the settings there and see what we need to do to get this to work how we expect it. I've got it set up. I've set the volt window. That's what they call the volt window, the height, to 30 volts. I've clicked AC because it wasn't in AC before. And now you can see we do have that sine wave on the screen, and it does have an acquisition window there. So it's not like continuously running away. It's like you're saying give me a reading and it sits there and actually takes a reading for a while, but that's fine. Do what this bit here is long press to add a cursor. Which bit do I long press? Okay. Oh, that's so cool. So you can see there, look, 27 volts and then zoop down to minus 27, zoop up to 27 minus. I have my DSO shell hooked up. I know it's a little bit tiny, so you probably can't quite see it, but on the scope trace here, it is actually showing a very similar swing where it's sort of plus or minus 20. The frequency, it's showing you the frequency of 50 hertz. It's showing you the duty cycle. It's showing you the Vmax, the Vmin. I mean, you are getting a lot of extra information here all the time, because this is really trying to emulate one of those bench power supplies. It's giving you all of that good stuff. Here you have to kind of go with the flow a little bit. It's a little bit simpler. But it does the job, I'd say. It's telling you probably what you need to know as a hobbyist. It's everything you need. And it's just showing you that because this is really a wireless data acquisition device. So if you think of it as an analog to digital converter and it's running on Bluetooth, it can't necessarily run continuously because that would use up too much power. So it's always going to have certain limitations, whereas of course something like this can just run flat, balls to the wall, grabbing data and just showing it to you on the screen. And it's probably got enough horsepower, just enough horsepower to give you all those standard oscilloscope functions. Now, technically your phone though could do a heck of a lot more, right? It has the capacity to be able to do that. That's fine. Anyway, let's move this aside. I think we've shown it does work close enough. It seems to be the same results as another reference. I'm good with that. Again, with AC and transformers and things, and you have RMSs and things like that, there's always a little bit of fudge factor. But where there is no fudge factor, of course, is when you have a power supply. So the next stage of this, of course, is that we can plug this into here. And interestingly enough, we can actually move this back into the voltmeter, and you see that voltage there. Let's see, as we plug it into our power supply, there's no load, but we can plug it in, because if our power supply had a fault, and believe me, I had a fault on one of these because a rectifier that I salvaged from a motherboard was a dead short rectifier. Like all 4 pins on the rectifier were shorted together. Unbelievable. Yeah, so when I'd plug something in like this, it would pop a transformer. Bad news. But you can see here, this hasn't gone to zero. The transformer's still running. It's still making a nice wave pattern. In fact, you'll see it now if we go into the oscilloscope. It's still running as you'd expect it. Great. Now we're going to take these probe clips off and we're going to move now more to the output end, and I want to see some direct readings, so I'm going back into Multimeter. I'm kind of liking this gadget, honestly. I do get sent a lot of useless gadgets, but this time it's a good gadget. Now this power supply is set with a plus and minus 5 volts power supply, and obviously stay tuned in future videos because I'm going to build one of these for you and tell you what it does, and you'll be able to have a look, get some motherboards off me or get the device. We're calling it the PSU boy, the SU boy. So I'm just holding now we're on AC, we want DC. We want DC voltage because it takes AC and it turns it into DC, but it gives you plus or minus 5 volts DC. So you can see we're on the negative side and we're getting the minus 5 volts because the middle wire here is the ground. That's like your black wire normally. And then if we go to the other side, you can get 5 volts. There we go. And it's just a touch. It's a kiss under 5 volts. Now, I think that's actually correct because of the way I've wired these guys in. So they are a little bit low. They're a little bit low, but that's fine. They're within tolerance for most 5 volts gadgets, put it that way. And you can see there we're getting the results we need. Of course, my phone is continuing to click and clock and make noises. But that's pretty much it. Now there is one more thing. If you've got something that's running over a longer period of time, so it's basically the same technology as that oscilloscope, but what they're doing is having a much longer time base. You could hook something on like this and then start logging. And I like that. It says tap again to stop logging, and you can see what it's doing. It's got 30 seconds here written on the screen. So every 30 seconds it's going to check and take a reading. So you go, okay, that's kind of cool. I mean, I'd like actually a faster reading if I can actually set that up. Yes, I can. Let's set it to every 1 second. And it actually tells you how much log time at this interval. So it's saying for a 1 second interval, it'll give you 103 minutes, interestingly enough. Now, I would expect the values to be showing on the screen, but I'm not showing that just yet. Interesting. I'm not seeing that live update, so it could be me. But anyway, let's now unplug it. So I'm pulling the mains out from the back. So let's say that was an event. Oh, I see. It says tap retrieve button. Oh, I see. So it says you have to tap the retrieve button to get it. So the logging is actually performed in here. This has the memory and then it's downloaded from here. Fantastic. Interesting. But you can see quite clearly there the voltage dropping as I unplugged it, and that would be the use case for that. But I would be quite curious to see what, so if we take one measurement an hour, let's say you're checking the battery voltage for a solar system, for example, then you're running it at that. It's saying here it would take 8 months. 8 months before this memory would be full on that, and that's cool. And then you could just come and retrieve that later. So that's really fantastic, because if you've got something like a solar thing, you want to see it going up and down, day, night, day, night, day, night, maybe month after month after month. You want to take all those average readings. Then what do you do with it once you've got that? It's only on the screen, I think, for now. I'm not sure. We'd have to check all the instructions and read, but I didn't see anything obvious to me about downloading that. But that would be what I'd want to do next, of course. If I've been taking months of data, I'd definitely want to download it. So let's have a look in the other parts of the application. You've got the tech specs here. So that's basically telling you the data that's on the data sheet, which is kind of interesting. And then you can have various devices, of course. Oh, they have different ones, and maybe I should have updated to 1.5, but there you go. 1.5 software might be slightly better, who knows. But just on the surface of it, as it is, I would absolutely no doubt suggest that anybody who doesn't have a meter and really wants to take something to the next level, without investing in the full oscilloscope setup, this could be a really good option for you. Admittedly, the DSO scope, shell, these things like that, they're not really that expensive, and they're actually significantly less than this guy. So you have to have a think about your use case and what you're going to do with it. I do like the using on the phone. Now, something that is super exciting about this, and this is where it really will start to make the difference to you, is that they do have an open source API. I don't know if it's quite released, but I was reading the documentation. Open source API for this, which means you can hook it up to your own apps or write your own software for automation or data logging. And that is really where there's a massive difference on this. Being able to have some really nice commodity hardware that you can use in your designs for setting up your measurement station or your devices could be really handy to you. So please consider it if you want one. Click on the link down below. I've got a little affiliate link down there. I don't know what I would get for it, but click that one. And as ever, comments down below, and thank you so much for watching.